Today we're going to look at the distributive property and multiplying binomials. This is what we've learned so far. When you add and subtract polynomials, you add the coefficients on like terms, and remember, key thing here, the powers never change. When I ask you to add x to the fifth plus x to the fifth, the powers never change, and you add the coefficients, and it's 1 plus 1, that's 2x to the fifth. 8x cubed minus 10x cubed. In this case, we subtract the coefficients. 8 minus 10 is negative 2, x cubed. The powers never change. If I have negative 7 of some number, and I take away 2 more of them, that's negative 2, in this case, A, B, C. Remember that when you add, the powers never change. Then we multiplied. When you multiply polynomials, you multiply the coefficients and add the powers on like bases. Remember, you can only add like terms. When you're multiplying, that's completely different. I'm going to take 1 times 1, and that's going to be 1, and I don't need to put that 1. X to the fifth times x to the fifth, well, there are 5 x's there multiplied, and 5 more here. That means altogether there are 10 multiplied. And as I said, you don't need the 1. Negative 8x cubed times 10x cubed. Negative 8 times 10 is negative 80. Remember, that sign always goes in front, the negative. This is x times x times x. There are 3 of them, and there are 3 more here. Altogether, there are 6 x's multiplied. Add the powers on like bases. Negative 7 times negative 2 below makes positive 14. A to the first times a to the first makes a to the second. B times b, that makes b to the second because it's b to the first times b to the first. Add them, the powers. And c times c makes c squared. We saw a few examples on the last assignment of the distributive property, where we take the number in front times every number inside. Remember that you're multiplying, and when you multiply the coefficients and add the powers on like bases. 3x squared times 2x cubed, 3 times 2, that's 6x to the fifth. We add the powers on like bases. 3x squared times negative 4x squared, 3 times negative 4 is negative 12, x to the fourth, because the powers are 2 and 2, that makes 4. Plus 3x squared times positive 5x, 3 times 5 is 15. This is x to the first. X to the first times x squared is x to the third. And for the last term, 3x squared times 2, 3 times negative 2 is negative 6. X squared, and there's no other x's here, so it's just an x squared. Our last example here, distributive property, I'm going to take this to both. Negative 4 times 7 is negative 28. X squared times x cubed, that's x to the fifth. We're adding our powers. Y cubed times y squared, that's y to the fifth. Negative 4 times negative 3 is positive, watch out for your signs there, positive 12. X squared times x squared is x to the fourth. And y cubed times y to the first makes y to the fourth. Today we're going to introduce multiplying binomials. This is called foiling. I'll explain what that means in a moment. Someone noticed that if I take 15 times 17, of course if I have a calculator, I can just work that out. But I want to point out there's a special case of the distributive property that allow me to multiply this. I can turn 15 into 10 plus 5 and 17 into 10 plus 7 and FOIL. F stands for first. That's 10 times 10, which is 100. And then I can take the 10 to the 7. 10 times positive 7 is positive 70. Notice how I took the 10 to both. I took the first, 10 times 10, and the O stands for outer. 10 times 7 is outer. I stands for inner. That's the 5 times the 10. 5 times 10 is 50. And L stands for last. That's the 5 times the 7, which is 35. Notice how this looks like the distributive property. I took the 10 to both and then the 5 to both. Now, of course, you wouldn't multiply this way, but I want to show you that it works because we're going to use it with variables. Let's work this out. 100 plus 70 is 170, plus 50 is 220, plus 35 is 255. And if I just go to a calculator and I take 15 times 17, that calculator says 255. My point here is that this process works, which means we can apply that process when multiplying binomials that have x's and y's and different variables in them. A binomial reminder means two terms. There are two terms here and two terms there. A monomial is one term, binomial is two terms, trinomial is three terms. Now we're going to do what we did on the previous page. We're going to FOIL. We're going to take x times x, that's the first. O stands for outer, x times negative 3. I stands for inner, 2 times x. And L stands for last, 2 times negative 3. First, outer, inner, last. Look at the arrows. It's just like the distributive property. I take the x to both and then the positive 2 to both. You've got to keep track of your signs. X times x, don't confuse that with x plus x. X plus x is 2x. X times x is x squared because when you multiply, you add your powers, and 1 plus 1 is 2. X times x is x squared. X times negative 3 is negative 3x. I write minus 3x. Now I take the 2 to both. Positive 2 times x is positive 2x. And positive 2 times negative 3 is negative 6. Notice I write minus 6. Typically when you FOIL and you multiply binomials, the middle will simplify. Not always, but most of the time. This is x squared. These are like terms, and I'm adding and subtracting. The powers never change when you add and subtract. Add the coefficients. Negative 3 plus 2 is negative 1x minus 6. And as I said, you don't need to put the 1. The second example right here is the same question. It doesn't look like it, but it is. Students always want to try to distribute the square to both of those, but that doesn't work. And I think what they do is they confuse this situation. 3xy squared. This is completely different. I can square everything inside, and this is 9x squared y squared. I'm not really distributing, I'm just squaring everything inside. But because of this subtraction right here, that changes things. I want to point out that you can't distribute an exponent when you have subtraction or addition. For example, if I said 7 minus 5 squared, this is an example, and I tried to make this 7 squared minus 5 squared, because this seems like it ought to work. That would be 49 minus 25, and 49 minus 25 ends up being 24. Yeah, that looks good. But let me tell you that this does not work. These are not equal. I can show this to you really quickly. What is 7 minus 5? It's 2. And what is 2 squared? It's 4. Notice how these aren't the same thing. You can't distribute an exponent right here if you have addition or subtraction. It does not work. What do you do then? Well, you heard me say it. It's the same as this question. You just write it out twice. 4x minus 5 times 4x minus 5. And then just like the last question, we're going to FOIL. First, outer, inner, last. We're going to take the 4x to both. we're going to take the negative 5 to both. 4x times 4x, that's 16x squared. 4x times negative 5, that's negative 20x. Notice how I write minus 20x. Now we take the negative 5 to both. Negative 5 times 4x again. Negative 5 times 4x is negative 20x. And negative 5 times negative 5 is positive 25. As I mentioned, usually the middle will simplify. Negative 20x plus negative 20x is negative 40x plus 25. And you can't combine any of these either here or here because they're not like terms. That is your answer. The rest of this video is examples from your assignment. If you have a question on your assignment, fast forward ahead and find one like it. Now, it won't always be the same question number, but I have an example of pretty much everything on your assignment. Question 1, we're distributing. We're going to take the 6 to both. 6 times x, hey, that's 6x. And 6 times positive 5 is positive 30. You've done that stuff before. Now we're going to take x squared to both. X squared times 9, that's 9x squared. And x squared times negative x. Remember, this is x to the first, and that you're multiplying. And when you multiply, you add your powers. X squared times x to the first is x cubed, so that's minus x cubed. 4x times x, that's x to the first and x to the first, which makes 4x to the second. 4x times positive 9 makes positive 36x. 5x squared times 6x, that's x to the first, that's 30x cubed. Notice I added my powers, 2 plus 1 makes 3. And 5x squared times negative 4 makes negative 20x squared. When I take 5x squared times positive 4, there are no x's there, so x squared just stays x squared. Question 3, same kind of thing. I'm going to distribute to both. I'm multiplying, so I'm going to multiply my coefficients and add my powers. 5x to the fourth times 10x to the ninth. 5 times 10 is 50. X to the fourth times x to the ninth is x to the 13th. 5x to the fourth times negative x to the seventh. There's a 1 here, and 5 times 1 is negative 5 in this case, because that's negative 1. And x to the fourth times x to the seventh makes x to the 11th. I can't combine these because they're not like terms. This is my answer. Question 6, more distributive property. This time I'm taking the 10x cubed to all three. And I didn't give you very many of these because I know it's a lot of typing. 10x cubed times 8x squared, multiply the coefficients, add the powers on like bases. That's 80x to the fifth. 10 times negative 5 is negative 50. We write minus 50. This is x to the first. X cubed times x to the first is x to the fourth. And the last one, 10x cubed times negative 1. Anything times 1 is itself. So this is negative 10x cubed. Question 7. We're multiplying binomials. This is FOIL, first, outer, inner, last. Just think of it as a special case of the distributive property. We're going to take the x to both, and then we're going to take the positive 3 to both. X times x is x squared. X times negative 5 is negative 5x. Now take the positive 3 to both. Positive 3 times x is positive 3x. And positive 3 times negative 5 is negative 15. Usually, the middle simplifies. Negative 5x plus 3x, we're adding now. We were multiplying originally, now we're adding, and we add, the powers never change. We add the coefficients. Negative 5 plus 3 is negative 2x minus 2x minus 15. More foiling. Take the 2b to both. Take the positive 1 to both. 2b times b is 2b squared. Multiply the coefficients. Remember there's a 1 here. 2 times 1 is 2, and b times b is b squared, because it's b to the first times b to the first. 2b times negative 3, that's negative 6b. Now take the 1 to both. 1 times b is positive 1b. Keep track of your signs, and I don't need to put this 1. 1 times negative 3 is negative 3. Now I'm going to combine the middle. I'm adding, the powers won't change. I add the coefficients. Negative 6 plus 1 is negative 5. So minus 5b minus 3. More foiling. Take the 4x to both. Take the negative 4 to both. 4x times 3x, that's 12x squared, because x to the first times x to the first is x squared. We add our powers. 4x times negative 2, that's negative 8x. Negative 4 times positive 3x, I'm multiplying right here, that's negative 12x. And negative 4 times negative 2 is positive 8. Combine the middle, 12x squared, negative 8x and negative 12x make negative 20x. Negative 4 times negative 2 makes positive 8. Question 18 is where students try to distribute an exponent over addition or subtraction, and that can't be done. What you need to do here is write it out twice, because f plus 6 quantity squared, quantity means parentheses, is f plus 6 times f plus 6. And this is just FOIL again, first, outer, inner, last. We take the f to both, then we take positive 6 to both. F times f is f squared. F times positive 6 is positive 6f. Next, take the 6 to both. 6 times f is 6f again, and 6 times 6 is positive 36. Simplify the middle, 6f and 6f, that makes 12f. F squared plus 12f plus 36. The last example, question 19, is just like the previous question, except we have a 5 in front here. But we can't distribute an exponent over addition and subtraction. We have to write this out twice and FOIL it. 5x plus 6 times 5x plus 6. Take 5x times 5x, that's 25x squared, because x to the first times x to the first is x squared. 5x times positive 6 is positive 30x. Now take the 6 to both. 6 times 5x is positive 30x again. And 6 times 6 is positive 36. Simplify the middle, combine like terms. 25x squared plus 60x plus 36.